November 12, 1943, Wehrmacht High Command bunker beneath the Zossen military complex, 30 kilometers south of Berlin. General Oberst Franz Halder, former chief of the General Staff, stared at the intelligence photographs scattered across the oak table with growing disbelief. The images showed American Liberty ships lined up in British ports, like a mechanized armada stretching beyond the horizon. "Impossible," he muttered, under his breath. "They cannot possibly maintain supply lines across both the Atlantic and Pacific simultaneously while building up for a European invasion." What Halder didn't know was that American industrial production had already exceeded the combined output of Germany, Italy, and Japan by a staggering 40%, and this was only the beginning. The morning briefing had begun routinely enough. Major Wilhelm Ziegler, from the Abwehr Intelligence Service, had presented what appeared to be another exaggerated Allied propaganda report. According to captured documents and aerial reconnaissance, the Americans were not only supplying Britain with massive quantities of war materials, but simultaneously supporting Soviet forces through the dangerous Arctic convoy routes, while maintaining a growing Pacific fleet that was island-hopping across the Central Pacific. The numbers seemed fantastical. Liberty ships being completed every 42 days, with some shipyards claiming construction times as low as 4 days and 15 hours. Steel production figures showed American mills producing more than 89 million tons annually, compared to Germany's 34 million tons under constant bombing pressure. Ziegler's intelligence reports contained details that defied German understanding of industrial logistics. The port of Baltimore alone was handling more cargo tonnage monthly than Hamburg had processed in its peak peacetime year. American shipyards were operating with 3 full shifts, supported by floodlighting systems that turned night construction into daylight operations. The Kaiser shipyards in Richmond, California, employed women welders who had never seen a ship before 1941, yet were achieving construction quality that exceeded traditional European shipbuilding standards. These workers followed standardized blueprints and prefabricated assembly techniques that eliminated the skilled craftsman bottlenecks that limited German naval construction. Oberst Heinrich Müller, a logistics specialist who had witnessed the Wehrmacht's supply struggles on the Eastern Front, shook his head in bewilderment. "Sir, our intelligence indicates that American convoy PQ-19 delivered over 99,000 tons of supplies to Murmansk last month alone. Simultaneously, their Pacific forces consumed nearly 2 million barrels of fuel oil supporting operations from the Aleutians to Guadalcanal." The mathematical impossibility of coordinating such operations across 24,000 kilometers of ocean while maintaining a strategic reserve for European operations defies all known principles of military logistics. The veteran officer had personally experienced what happened when German supply lines stretched beyond 300 kilometers during Operation Barbarossa. The idea that any nation could effectively coordinate multi-theater operations, separated by 2 oceans, seemed like strategic fantasy. Captain Johann Weber, recently returned from North Africa, where he had observed American supply capabilities firsthand, interrupted the discussion with a haunted expression. "Gentlemen, I have witnessed their logistics operations personally. At the port of Casablanca, I watched American engineers unload an entire mechanized division in 72 hours. The harbor operated 24 hours daily, with artificial lighting systems that turned night into day. Landing ship tank vessels the size of small cruisers discharged tanks, trucks, artillery pieces, and supplies with industrial precision. But what truly shocked me was the casual efficiency. American soldiers were eating ice cream while unloading ammunition, as if abundance was their natural state of being." Weber continued his testimony with details that haunted his fellow officers. "They possess mobile repair shops that can rebuild tank transmissions on the beach. Their mechanics carry more spare parts in portable kits than our entire Africa Corps received through Mediterranean supply runs. I observed American tank crews discarding vehicles with minor mechanical problems because requesting replacement tanks was faster than performing repairs. This approach contradicts every principle of German military economy, where each piece of equipment represents irreplaceable strategic value that must be maintained through individual craftsmanship and careful resource management. The captain's account included observations about American personnel policies that German officers found incomprehensible. Their soldiers rotate between combat zones and training facilities on predetermined schedules, as if warfare follows industrial production cycles. Combat veterans return to the United States for technical education, rest periods, and specialized training before deployment to different theaters. This systematic approach treats human resources like industrial components that require maintenance, upgrade, and systematic replacement rather than irreplaceable assets that must be preserved through careful deployment and tactical excellence. Weber's account contradicted everything German military doctrine taught about the friction of war and the inevitable breakdown of complex systems under operational stress. Before we move on, please subscribe to help our channel get 1,000 subscribers. This is really important for us. Thanks in advance. Let's move on. The strategic implications began crystallizing as the intelligence officers processed the mounting evidence. Capitaine C. Friedrich Rouge, a naval logistics expert, pointed to a map of global shipping routes marked with red pins, indicating American convoy activity. If these reports are accurate, the Americans are operating simultaneous supply chains that require precise coordination between Pacific and Atlantic theaters. They are maintaining forward supply bases from Australia to Iceland, while simultaneously supporting Chinese forces through the Burma Road and Soviet forces through Persian Gulf routes. The fuel consumption alone would exceed 15 million barrels monthly, yet their domestic petroleum production continues uninterrupted. Our U-boat campaigns have sunk over 14 million tons of Allied shipping, but their shipbuilding capacity appears to exceed our destruction rate by a factor of 3 to 1. The room fell silent as the magnitude of American industrial mobilization became apparent. General Major Ernst Köstring, who had served as military attaché in Moscow, provided additional context that deepened the German officers' concern. Our Russian sources report that American Lend-Lease deliveries include not only weapons and ammunition, but complete industrial equipment, locomotives, communication systems, and even raw materials for Soviet munitions production. The Studebaker trucks we encounter on the Eastern Front carry American radios, spare parts, and maintenance manuals, translated into Russian. This suggests a level of industrial integration and forward planning that transforms warfare from tactical engagement to industrial competition. The scope of Lend-Lease operations revealed coordination capabilities that German planners found strategically devastating. American factories were simultaneously producing equipment for British forces in North Africa, Soviet armies on the Eastern Front, Chinese forces in Burma, and Australian units in the Pacific, while maintaining domestic production for rapidly expanding American military forces. Each recipient nation received equipment specifically configured for their operational requirements, climate conditions, and tactical preferences. British forces received desert-modified Sherman tanks with dust filters and cooling systems, while Soviet forces received winterized versions with improved heating and cold weather starting systems. This customization required production planning and supply chain coordination that German industry could not match even for domestic requirements. Köstring's intelligence reports detailed the systematic approach to international military cooperation that enabled such coordination. American liaison officers worked directly with Allied procurement agencies, technical specialists, and field commanders to identify requirements months before delivery schedules. They maintained detailed databases, tracking equipment performance, maintenance requirements, and replacement needs across multiple theaters and Allied forces. German international cooperation relies on diplomatic negotiations, formal agreements, and limited technical exchanges. American cooperation operates like industrial coordination between different divisions of the same manufacturing corporation. The psychological impact of these revelations rippled through the assembled officers as they began comprehending that they were not facing a traditional military adversary, but an entire industrial civilization mobilized for total war. Colonel Victor von Lossberg, an operations officer who had helped plan the initial phases of Operation Barbarossa, stared at production charts showing American aircraft manufacturing. These figures indicate monthly aircraft production exceeding our annual capacity. If accurate, American factories are completing more fighter aircraft in 30 days than our entire Luftwaffe possessed at the beginning of the Russian campaign. The strategic mathematics are overwhelming. We calculated that defeating the Soviet Union required destroying existing Red Army forces, but we never anticipated fighting replacement armies equipped with unlimited American industrial output. Major Hans-Georg von Seckendorff-Aberdar, a former cavalry officer turned mechanized warfare specialist, examined intelligence photographs of American tank factories with professional amazement. The Detroit Arsenal tank plant covers an area larger than the entire Krupp Works in Essen. According to these reconnaissance images, the assembly lines are producing M4 Sherman tanks at a rate of one completed vehicle every 90 minutes around the clock. The standardized production methods allow interchangeable parts manufactured in different cities to be assembled into functional weapons systems. This industrial approach to warfare represents a fundamental transformation from traditional military production, where each weapon system required individual craftsmanship and specialized components. As the briefing continued into the afternoon, the accumulated weight of evidence painted an increasingly stark picture of American capabilities that challenged every assumption underlying German strategic planning. The revelation that American forces were simultaneously supporting major offensives in multiple theaters while building up for additional operations represented a paradigm shift in modern warfare that German military theory had not anticipated. The transformation of American industrial capacity from peacetime production to wartime dominance had begun years before German intelligence recognized its strategic implications. Henry J. Kaiser, a construction engineer who had never built a ship before 1941, revolutionized maritime construction by applying assembly line principles to shipbuilding. His Richmond Shipyard No. 2 in California became a mechanical marvel that German naval architects initially dismissed as impossible propaganda. The traditional German shipbuilding approach required 18 months to complete a destroyer, employing skilled craftsmen who hand-fitted each component. Kaiser's shipyards were completing Liberty ships in an average of 42 days, using prefabricated sections, manufactured inland, and transported by rail to coastal assembly points. Oberst Franz von Vera, a Luftwaffe intelligence officer who had escaped from British captivity and observed American industrial facilities during his journey, provided first-hand testimony that shattered German preconceptions about American manufacturing capabilities. The Willow Run bomber plant outside Detroit stretches for 1.6 kilometers in a single building. I watched through reconnaissance photographs as they produced B-24 Liberator bombers on an assembly line, moving at precisely one aircraft per 63 minutes. The facility employed women workers operating precision machinery with the same efficiency as our most experienced Messerschmitt technicians. The systematic coordination required for two ocean operations revealed American organizational capabilities that German staff officers found incomprehensible. General George Marshall's War Department had created the Army Service Forces under Lieutenant General Brehon Somervell, a logistics command structure that controlled global supply chains with mathematical precision. The port of Newport News, Virginia, could load a Liberty ship with 5,000 tons of military equipment in 18 hours, while simultaneously coordinating with Pacific ports to ensure balanced resource allocation between European and Asian operations. American innovations in mass production techniques revolutionized manufacturing processes that German industry had refined over decades of traditional craftsmanship. The Ford Motor Company's conversion to aircraft engine production demonstrated industrial flexibility that challenged fundamental assumptions about specialized manufacturing. Henry Ford's engineers redesigned the Rolls-Royce Merlin engine for mass production, reducing manufacturing time from 150 hours to 18 hours per unit while maintaining performance specifications. The psychological impact of American industrial mobilization extended beyond mere production statistics to represent a fundamental transformation in the nature of modern warfare. Colonel Claus von Stauffenberg, before his involvement in resistance activities, analyzed American supply chain management with professional admiration mixed with strategic despair. They have transformed warfare from an art requiring genius and improvisation into an industrial process requiring systematic organization and unlimited resources. German military excellence depends on superior training, tactical innovation, and individual initiative overcoming material disadvantages. American military effectiveness depends on overwhelming material superiority, supported by systematic organization that minimizes the importance of individual brilliance or tactical creativity. The first direct encounter with American logistics supremacy occurred during Operation Torch in November 1942, when German forces in North Africa witnessed supply operations that defied every principle of military logistics they had studied. General Major Georg von Bismarck, commanding the 21st Panzer Division, reported to Rommel's headquarters with barely contained shock. The Americans have unloaded an entire armored division at Casablanca in 4 days. Our intelligence calculated this operation would require minimum 3 weeks using conventional methods. They employ specialized landing ship tank vessels, each capable of carrying 60 Sherman tanks directly onto beaches without port facilities. These vessels operate in coordinated waves with mathematical precision, supported by floating repair shops, fuel barges, and mobile supply depots that eliminate traditional logistics bottlenecks. Major Hans Joachim Marseille, the legendary Luftwaffe ace, transmitted his final combat report before being shot down over Egypt with observations that would haunt German aviation commanders. American fighter formations carry unlimited ammunition and fuel. I have engaged P-40 Warhawk squadrons that maintain combat for 45 minutes without fuel concerns, then return to base, refueled, rearmed, and return to combat within 90 minutes. Their pilots fly 3 combat missions daily, while maintaining aircraft serviceability rates exceeding 90%. German pilots are rationed to single combat sorties due to fuel shortages, and our aircraft availability rarely exceeds 60% due to maintenance limitations and parts shortages. The psychological transformation of German military thinking accelerated as captured American equipment revealed industrial capabilities that challenged fundamental assumptions about wartime production quality. Oberst Hermann Bauch, commanding the 11th Panzer Regiment, examined a disabled Sherman tank near El Alamein with professional amazement. The interior components display manufacturing precision equivalent to civilian automobile production. Electrical systems employ standardized wiring harnesses. Instruments use identical gauges across different vehicle types, and mechanical components show machining tolerances that exceed our Panzer IV standards. But most significantly, the instruction manuals are printed in color with detailed maintenance procedures that enable crew-level repairs without specialized technical training. German armored vehicles require factory-trained mechanics for major maintenance, while American crews perform complex repairs using field manuals and standardized replacement parts. The coordination between American production and battlefield requirements demonstrated supply chain integration that German logistics officers found incomprehensible. General Oberst Heinz Guderian, recalled from the Eastern Front to assess American tank warfare capabilities, analyzed captured Sherman tanks with growing concern. These vehicles incorporate design features that prioritize mass production over individual performance optimization. Standardized components allow rapid assembly, simplified maintenance, and interchangeable parts supply. The transmission system uses commercially available automotive components modified for military service, enabling unlimited replacement parts production using civilian manufacturing capacity. German tank design emphasizes technical sophistication and individual vehicle superiority, but American design emphasizes unlimited production and simplified logistics support. Guderian's technical analysis revealed design philosophies that reflected fundamentally different approaches to military equipment development. German engineers optimized individual vehicle performance through complex mechanical systems, advanced metallurgy, and precision manufacturing that required specialized production facilities and highly skilled technicians. American engineers optimized production efficiency through simplified designs, standardized components, and manufacturing techniques that could employ civilian automotive workers with minimal retraining. German Panzer tanks incorporated sophisticated transmission systems, advanced armor designs, and precision mechanical components that maximized individual vehicle capabilities. American Sherman tanks incorporated proven automotive technology, simplified mechanical systems, and standardized maintenance procedures that maximized production rates and field serviceability. The implications extended beyond individual vehicles to encompass entire armored divisions that operated with supply chain integration, impossible under German resource constraints. American tank units received standardized ammunition, interchangeable spare parts, and maintenance support that functioned across different vehicle types within the same unit. German armored units operated diverse vehicle types, requiring specialized ammunition, unique spare parts, and maintenance expertise distributed across multiple suppliers and production facilities. American standardization enabled rapid repair, simplified logistics, and consistent performance across entire armored formations. German diversity enabled tactical flexibility and technical superiority in individual engagements, but created insurmountable logistics complications during sustained operations. The scale of American replacement capabilities became apparent through prisoner interrogations that revealed rotation policies impossible under German resource constraints. Hauptmann Wolfgang Luth, a U-boat commander captured in the Atlantic, reported American naval procedures that astonished his interrogators. American destroyer crews rotate every 18 months between combat zones and training facilities. Fresh crews arrive with 6 months intensive training, full equipment allocations, and unlimited spare parts inventories. American shipyards simultaneously produce replacement vessels, upgrade existing ships, and maintain strategic reserves that exceed our entire naval construction program. Their crews discuss returning home for leave and technical education as routine expectations rather than exceptional privileges. The industrial foundation supporting American military operations revealed capabilities that transformed modern warfare from resource management to resource application. Colonel Rudolf Schmondt, Hitler's military adjutant, compiled intelligence reports that painted an increasingly stark picture. American aircraft production exceeds our annual capacity every 2 months. Their factories complete fighter aircraft faster than our training programs can produce pilots. The Boeing Company alone employs more workers than our entire aircraft industry, while simultaneously supporting civilian aviation, transport aircraft production, and experimental development programs. This industrial base operates independently of military priorities, providing unlimited capacity for weapons production without compromising civilian manufacturing or research activities. American innovations in military standardization eliminated logistics complications that plagued German forces throughout the war. Major Friedrich von Seckendorf examined captured American small arms with tactical appreciation. The M1 Garand rifle represents mass production efficiency applied to individual weapons. Each rifle demonstrates identical specifications, interchangeable parts, and simplified maintenance procedures. American soldiers carry standardized ammunition, cleaning kits, and replacement parts that function across different weapon systems. The industrial foundation supporting American military operations revealed capabilities that transformed modern warfare from resource management to resource application. Colonel Rudolf Schmundt, Hitler's military adjutant, compiled intelligence reports that painted an increasingly stark picture. American aircraft production exceeds our annual capacity every 2 months. Their factories complete fighter aircraft faster than our training programs can produce pilots. The Boeing Company alone employs more workers than our entire aircraft industry, while simultaneously supporting civilian aviation, transport aircraft production, and experimental development programs. This industrial base operates independently of military priorities, providing unlimited capacity for weapons production without compromising civilian manufacturing or research activities. American innovations in military standardization eliminated logistics complications that plagued German forces throughout the war. Major Friedrich von Seckendorf examined captured American small arms with tactical appreciation. The M1 Garand rifle represents mass production efficiency applied to individual weapons. Each rifle demonstrates identical specifications, interchangeable parts, and simplified maintenance procedures. American soldiers carry standardized ammunition, cleaning kits, and replacement parts that function across different weapon systems. German small arms employ superior engineering and individual craftsmanship, but require specialized ammunition types, unique maintenance tools, and parts that are not interchangeable between manufacturers or production batches. The psychological impact of American supply abundance became apparent through battlefield observations that contradicted German expectations about wartime resource management. Oberst Hans Ulrich Rudel, the legendary Stuka pilot, reported after engaging American ground forces, American soldiers discard equipment rather than repair minor damage. I observed infantry units abandoning vehicles with mechanical problems and requesting immediate replacements. Their supply system treats complex military equipment as disposable items rather than precious resources requiring careful maintenance. This approach reflects unlimited production capacity that enables replacement rather than repair as standard operating procedure. Rudel's observations extended to American aviation operations that revealed resource abundance. German pilots found psychologically devastating. American fighter pilots fly multiple combat missions daily with fresh aircraft, full ammunition loads, and unlimited fuel allocations. Their squadrons maintain aircraft availability rates exceeding 90% through systematic maintenance procedures and unlimited spare parts inventories. German pilots are limited to single combat sorties due to fuel rationing, and our aircraft availability rarely exceeds 60% due to parts shortages and maintenance limitations imposed by resource constraints. The contrast in pilot training reflected broader differences in resource allocation that affected combat effectiveness at fundamental levels. American flight training programs provided 300 hours of instruction before combat deployment, including formation flying, gunnery practice, navigation training, and emergency procedures using dedicated training aircraft and instructors. German pilot training had been reduced to 40 hours due to fuel limitations, using operational aircraft diverted from combat missions and instructors recalled from frontline duties. This training differential translated directly into survival rates, combat effectiveness, and operational capabilities that could not be overcome through tactical innovation or individual courage. American pilots arrived at combat units with technical proficiency that German pilots required months of combat experience to develop, if they survived long enough to gain such experience. The strategic implications crystallized as German commanders recognized that American logistics capabilities represented a fundamental transformation in the nature of military conflict. General Walther Model, analyzing intelligence reports from multiple theaters, concluded, "We are not fighting a traditional war where tactical superiority and operational innovation can overcome material disadvantages. The Americans have transformed warfare into an industrial competition where victory depends on production capacity rather than military excellence. Their supply system operates like a mechanical process that converts raw materials into battlefield superiority through systematic organization and unlimited resources." German military traditions emphasize individual initiative, tactical creativity, and operational art overcoming material limitations. American military effectiveness depends on eliminating material limitations through industrial abundance and systematic organization. The mathematical impossibility of competing with American production became undeniable when German intelligence compiled comprehensive comparisons that revealed the true scale of industrial disparity. By 1944, American factories were producing 47,400 tanks annually, while German production peaked at 27,300 tanks under optimal conditions that no longer existed due to constant Allied bombing. General Oberst Heinz Guderian, the father of German armored warfare, examined these statistics with the clinical detachment of a professional facing inevitable defeat. The Americans complete more Sherman tanks in 6 weeks than we can produce Panzer IVs in 12 months. but quantity represents only the visible dimension of their advantage. Each Sherman incorporates 500 standardized components manufactured in different cities and assembled with precision tolerances that exceed our hand-fitted systems. The revelation that American industry operated as a coordinated system rather than competing individual companies shattered German assumptions about capitalist inefficiency. Major General Friedrich Paulus, captured at Stalingrad and now providing intelligence analysis, reported with bitter admiration, "The Ford Motor Company's Willow Run plant covers 4.3 million square feet under a single roof. This facility alone employs 42,000 workers producing B-24 Liberator bombers, at peak rate of 1 aircraft every 55 minutes around the clock." The plant operates 3 shifts with mathematical precision, supported by dedicated railway lines, power substations, and material handling systems that eliminate production delays. German aircraft manufacturing relies on multiple smaller facilities, producing limited quantities of different aircraft types, an approach that maximizes engineering sophistication but cannot achieve mass production efficiency. American innovations in industrial organization challenged fundamental European concepts about skilled labor and manufacturing quality. The Consolidated Aircraft Corporation employed women workers who had never seen military equipment before the war, yet achieved production quality that exceeded traditional German craftsmanship standards. Oberst Adolf Galland, general of the fighter forces, analyzed captured 51 Mustang fighters with professional respect. These aircraft demonstrate manufacturing precision that rivals our finest hand-built prototypes, yet they are produced on assembly lines by workers with minimal aircraft experience. The secret lies in systematic quality control, standardized components, and production techniques that eliminate human variability. German aircraft production relies on master craftsmen whose individual skills require years to develop and cannot be rapidly scaled for mass production. The petroleum dimension of American logistic superiority created strategic hopelessness among German planners who understood that modern warfare essentially consisted of burning refined petroleum products at maximum sustainable rates. Admiral Karl Donitz, commander of the German Navy, calculated that American domestic petroleum production exceeded 4 billion barrels annually, while synthetic fuel production represented Germany's only significant petroleum source at 12 million barrels yearly under optimal conditions. American training exercises consume more aviation gasoline than we allocate for combat operations. Their pilots receive 300 flight hours of training before operational deployment, compared to our current allocation of 40 hours due to fuel shortages. This training differential translates directly into combat effectiveness, pilot survival rates, and operational capabilities that cannot be overcome through tactical innovation or individual courage. The coordination required for simultaneous two-ocean operations revealed organizational capabilities that German staff officers found impossible to comprehend within traditional military frameworks. General Alfred Jodl, Chief of Operations Staff, studied American convoy coordination with growing amazement. They maintained precise scheduling for merchant ships departing New York for Liverpool, while simultaneously coordinating Pacific convoys from San Francisco to Brisbane. Individual Liberty ships carry predetermined cargo loads calculated to support specific military operations, separated by 24,000 kilometers of ocean. This level of coordination requires communication systems, planning capabilities, and organizational integration that exceeds our theoretical understanding of large-scale logistics management. American standardization eliminated maintenance complications that crippled German forces operating diverse equipment types under combat conditions. The United States military employed approximately 300 different vehicle types, compared to Germany's 1,500 vehicle variations that required specialized maintenance, unique spare parts, and technical expertise distributed across multiple manufacturers. Major Otto Carius, Germany's most successful tank destroyer commander, examined American maintenance procedures with tactical respect. American tank crews perform engine replacement in 4 hours, using standardized tools and interchangeable components. German tank crews require specialized equipment, factory-trained mechanics, and parts manufactured specifically for individual vehicle chassis numbers. American maintenance procedures are documented in illustrated manuals that enable crew-level repairs, while German technical maintenance requires specialized training and experience that cannot be rapidly replaced under combat conditions. The educational infrastructure supporting American military production created human resource advantages that German planners had not anticipated when calculating wartime industrial potential. American universities produced engineering graduates at rates that exceeded total German technical education capacity, while simultaneously conducting military research, training programs, and industrial development projects. Professor Werner von Braun, analyzing American rocket and electronics research, reported with professional admiration, "Their educational system operates like an industrial production line that converts high school graduates into technically competent engineers within 4 years." MIT alone graduates more electrical engineers annually than our entire Reich's technical education system. These engineers immediately enter positions supporting radar development, communication systems, proximity fuse research, and production optimization programs that maintain technological advancement despite wartime resource allocation. The strategic reserves maintained by American forces demonstrated resource abundance that German commanders found psychologically devastating. Colonel Joachim Pieper, commanding the 1st SS Panzer Regiment, reported after engaging American armored units in France, "They attack with equipment superiority of 3-1, knowing that destroyed vehicles will be immediately replaced from strategic reserves." American tank crews discuss rotation schedules, leave policies, and post-war civilian employment as routine expectations. German crews understand that disabled vehicles cannot be replaced, wounded personnel will not be evacuated promptly, and survival depends on equipment maintenance and tactical excellence overcoming material disadvantages. This psychological difference affects combat performance, risk assessment, and operational decision-making in ways that pure tactical training cannot overcome. American innovations in amphibious warfare capabilities created operational possibilities that German coastal defense planning had not anticipated. The development of LST landing ships, DUKW amphibious trucks, artificial harbors, and specialized beach assault equipment enabled major operations without capturing established port facilities. Admiral Friedrich Ruge, German naval construction expert, analyzed American amphibious innovations with strategic despair. They have eliminated the fundamental requirement for port facilities in amphibious operations. LST ships carry 60 tanks directly onto beaches, while DUGW vehicles transport supplies from ships to inland supply dumps without intermediate handling. The artificial mulberry harbors at Normandy provided port capacity equivalent to Dover within 6 days of D-Day. German coastal defense strategy relied on denying port access to prevent sustained Allied operations, but American amphibious capabilities bypassed traditional port requirements through technological innovation and industrial production of specialized equipment. The cumulative effect of American industrial mobilization represented more than quantitative superiority. It constituted a fundamental transformation in the nature of warfare that rendered traditional military excellence insufficient for strategic success. General Walther Model, Germany's defensive specialist, concluded his final strategic assessment with characteristic precision. "We have mastered the art of war as it existed throughout human history, where tactical brilliance, operational innovation, and individual courage could overcome material disadvantages through superior training and leadership. The Americans have created industrial warfare, where victory depends on systematic organization, unlimited resources, and production capacity, rather than military artistry. Our greatest tactical successes delay inevitable defeat rather than creating opportunities for strategic victory." The post-war testimonies of German military leaders revealed the profound psychological impact of confronting American industrial supremacy that had redefined the fundamental nature of military conflict. Field Marshal Erich von Manstein, considered Germany's most brilliant operational commander, reflected during his war crimes trial with characteristic analytical precision. We fought the Second World War with the concepts and capabilities of the First World War, believing that tactical excellence and operational artistry could overcome material disadvantages. The Americans fought with the concepts and capabilities of industrial civilization, treating warfare as a production problem, requiring systematic organization rather than military genius. Our defeat was not merely tactical or strategic. It represented the obsolescence of traditional military thinking in the face of total industrial mobilization. General Heinz Guderian, during post-war interrogations by Allied intelligence officers, provided perhaps the most comprehensive German assessment of American logistic supremacy. The shock was not simply that they could supply forces across two oceans simultaneously, but that they made such operations appear routine rather than extraordinary. Their convoy schedules operated with railroad precision, their supply allocation followed mathematical formulas, and their production planning anticipated requirements months before battlefield commanders recognized emerging needs. German logistics relied on improvisation, individual initiative, and making maximum use of limited resources. American logistics eliminated resource limitations through systematic planning and unlimited production capacity. The strategic implications extended far beyond World War II to establish principles of modern warfare that would dominate military thinking throughout the Cold War period. Admiral Karl Donitz, serving his war crimes sentence, analyzed the transformation with naval expertise. Traditional naval warfare emphasized individual ship capabilities, crew training, and tactical innovation overcoming numerical disadvantages. American naval operations demonstrated that systematic production, standardized training, and coordinated logistics could achieve decisive superiority through organized abundance rather than individual excellence. Their Liberty ship program alone produced more merchant tonnage than the entire German Navy possessed at the beginning of the war, while simultaneously supporting combat ship construction, amphibious assault vessels, and specialized support craft. The educational and technological foundations of American success created lasting advantages that German scientists and engineers recognized as fundamentally transformative. Wernher von Braun, recruited into the American space program, reflected on the systematic approach to innovation. German rocket development relied on individual brilliance, limited resources, and theoretical advancement, despite material constraints. American rocket development integrated unlimited funding, systematic research, industrial production capabilities, and educational institutions that could rapidly scale technical personnel. The difference was not intellectual capacity, but organizational systems that could convert theoretical knowledge into practical applications through coordinated effort and abundant resources. The psychological transformation of German military thinking represented acceptance that modern warfare required industrial capabilities that exceeded traditional military virtues. Colonel Joachim Paper, during his war crimes trial, acknowledged the paradigm shift with soldiers' directness. We were trained to believe that superior tactics, individual courage, and military tradition could overcome material disadvantages through fighting spirit and tactical innovation. The American success demonstrated that modern warfare rewards systematic organization, industrial capacity, and logistical coordination over individual military excellence. The soldiers' virtues of courage, initiative, and tactical skill remain important, but they cannot overcome systematic disadvantages in equipment, supply, and replacement capabilities. The long-term consequences of American two-ocean logistic supremacy established templates for global military operations that would define superpower capabilities throughout the 20th century. The techniques developed for coordinating simultaneous operations across multiple theaters became standard doctrine for NATO operations, Cold War deployments, and modern expeditionary warfare. General Alfred Jodl, executed for war crimes, but whose operational analyses remain professionally respected, had predicted during the war's final months, the Americans have created military capabilities that will dominate global strategy for decades. Their ability to project power simultaneously across multiple continents while maintaining domestic production and strategic reserves represents a new form of military organization that other nations cannot match without equivalent industrial and educational foundations. The industrial integration between civilian manufacturing and military production that shocked German observers became the foundation for America's Cold War military-industrial complex. The Ford Motor Company's conversion from automobile production to aircraft manufacturing, General Motors' transition to tank production, and Boeing's expansion from commercial aviation to military aircraft demonstrated industrial flexibility that enabled rapid scaling of military capabilities without sacrificing civilian manufacturing capacity. This integration created peacetime military production capabilities that could be rapidly expanded during crises, while maintaining technological advancement through continuous research and development programs. Modern military analysts recognize the German shock at American two-ocean logistics as a historical turning point that marked the transition from traditional warfare to industrial warfare. The systematic coordination required for simultaneous Atlantic and Pacific operations established organizational principles that influenced modern military logistics, NATO coordination procedures, and contemporary expeditionary warfare capabilities. The standardization of equipment, integration of supply chains, and systematic approach to military production that amazed German observers became standard practices for modern military organizations worldwide. The educational and technological infrastructure that supported American wartime production created lasting advantages in scientific research, industrial innovation, and technical education that extended far beyond military applications. The university research programs that developed radar systems, proximity fuses, and advanced metallurgy during the war became the foundation for post-war technological leadership in electronics, aerospace, and materials science. The engineering education capacity that produced 50,000 graduates annually during the war established American dominance in technological innovation that continued throughout the Cold War period. The strategic lessons learned from German analysis of American logistics supremacy influenced post-war military planning and alliance coordination throughout the Western world. The systematic approach to logistics coordination, standardized equipment procurement, and integrated command structures that enabled two-ocean operations became templates for NATO organization, joint military exercises, and coalition warfare planning. The recognition that modern warfare required systematic organization rather than individual military excellence transformed military education, staff planning, and strategic thinking throughout the democratic world. NATO's adoption of standardized ammunition, interchangeable equipment specifications, and coordinated logistics procedures reflected direct lessons learned from American World War II operations. The alliance's ability to coordinate multinational forces, integrate diverse national capabilities, and maintain sustained operations across multiple theaters employed organizational principles that German staff officers had first observed with shock during the war. The systematic approach to training, equipment standardization, and logistics coordination that enabled American two-ocean supremacy became foundational principles for Western military alliance operations. Modern expeditionary warfare capabilities employed by contemporary military forces trace their conceptual origins to American innovations that shocked German commanders during World War II. The ability to project power across global distances, maintain sustained operations without established base infrastructure, and coordinate simultaneous operations in multiple theaters requires systematic organization, industrial support, and logistics coordination that exceeded traditional military capabilities. The techniques developed for coordinating Atlantic and Pacific operations simultaneously established operational templates that influence contemporary military planning, joint operations, and expeditionary warfare doctrine. The integration of civilian industrial capacity with military production requirements that amazed German observers became standard practice for modern military-industrial coordination. The systematic approach to converting civilian manufacturing to military production, maintaining strategic reserves, and scaling production capacity during crises established principles that influenced Cold War military planning and contemporary defense industrial policy. The recognition that modern warfare required systematic coordination between civilian industry and military requirements, rather than traditional separation between military and civilian sectors, transformed strategic planning throughout the Western world. The ultimate legacy of American two-ocean logistics supremacy lies not merely in the achievement of simultaneous operations across multiple theaters, but in the demonstration that systematic organization, industrial coordination, and educational infrastructure could overcome traditional military advantages through sustained effort and abundant resources. The German general's shock represented recognition that warfare had fundamentally changed from an art requiring individual genius to a science requiring systematic coordination of industrial civilization's productive capacity. If you've watched this far, you must have liked the video. Please write which city you're watching from in the comments. And if you still don't like it, leave a like. See you in the next video.